Pyramids and cones are kind of the same shape because you've got how many bases? Just one. So when we were yesterday doing 2-base area, today there will be just 1 base area. And then what are the shapes that go up on pyramids? What shapes are they? They're triangles. How do you do the area of a triangle? 1/2 base times height. So if you'll kind of look at what I'm showing here, okay, so 1/2 base would be this edge, and then the height has to go along this face because you're doing the height of the triangle. So if you do 1/2 this edge times that slant, and then 1/2 this edge times that slant, 1/2 this edge times that slant, 1/2 this edge times that slant. Yeah, I took it times 4 because my base has 4. But didn't I do 1/2 times the perimeter of the base? And I always multiplied by this slant for the height. Okay, that's part of what you'll see in the formula. So let me, I guess, maybe I better back up. Okay, so we talked about the pyramid. I guess we better get the definitions. Okay, a pyramid is a solid with a base that is a polygon. And its lateral faces are triangles. That's what I was asking you just a little bit ago. Lateral faces are triangles with a common vertex. So they all meet at one point. The height of the pyramid is the perpendicular distance between the vertex and the base. So if I were to draw the height of this pyramid, go from the base to that vertex perpendicular, that's going to be the height of the pyramid. I'll have to scroll it so you can see what's on the bottom. Height is the perpendicular, and then there's what's called the slant height, which, as I was talking through with you, that's the height of the triangles that are on the faces. That's the slant height. The slant height of a pyramid is the height of any lateral face. It's represented by the letter, and this should look more like a cursive L, by the letter L. And so if I would draw a slant height, it goes to the middle of the side. It's perpendicular. It's not going very straight. I'm trying to stay out of your way. I can't draw very straight that way. So this one that's going to the side, that's your slant height. The one that went perpendicular to the top, that was your actual height. So some of our formulas will use the slant height and some will use the perpendicular height. Since we're talking about surface area, the slant height is the one that's on the surface. So that will be the one that's used in the surface area formula. Got that screen done? Not quite. We talked about nets, either yesterday or day before. What would the net of this pyramid that I'm holding look like? A square with 4 triangles, one for each side. Did we draw that one? So again, while I'm waiting for people to finish their notes. The formula's gonna have one base area plus those triangles will be 1/2 perimeter of the base times the slant height. Not the perpendicular height, the slant height. To the end of the notes now? All right, I'll move on. So I already talked about the net, so I'm going to skip that part. The surface area formula for a pyramid, and once you write it in your notes, and I think about putting it on your note card also. Pyramid would be the area of the base, so that capital B, plus 1/2 times the perimeter of the base times the slant height. I'm going to write that cursive. Yeah, they might give you the surface area and have you find what the slant height is or something like that. So it's possible. I don't think too much of that. I think on some they would maybe tell you the lateral area. And then I'd have to look through and refresh my memory on what's on there. But I think you probably not think a lot of what you're doing is just calculating. All right, got it down? No? No? Okay, I think yesterday I did a sample while it was showing, so maybe we could work on that. So let's make just the basic square base pyramid. And part of that would really be dashed the way I'm going to draw it. So I'm going to dash this. I'll go up about this high. If that's a square-based pyramid, let's make the base an 8 by 8 feet. And the slant height, which I'll draw here, that slant height is going to be 14. Find the surface area. How much would it take to cover that whole thing? Make sure we're doing it right. I guess let's list over here, what's the base area? Base is a square. How do you multiply to get its area? 8 times 8? 8 times 8, so 64 for the base area. What's the perimeter going to be? Okay, I'm not going to do the by 1/2 yet. So 32. And then what's the slant height? 14. So then I've got all the numbers, I just need to plug in. One base area is 64 plus 1/2 times 32 times 14. 288. And it would be square feet because we're doing surface area. See where I'm getting the numbers? Okay, so everyone done with the notes? We'll do some more examples. Okay, let's say this one has, it's a pretty big base. Let's say it's 20 by 20, and the slant height on it is 24. go inches. Find the surface area. If it helps seeing each of those listed, make your list of things. I'm going to make my list of separate things, see if it matches up with what you've got. Okay, base area should be 20 times 20, so that's 400. Perimeter should be 20 plus 20 plus 20 plus 20, which should be 80. And the slant height is 24. So if you got all of those, then the formula, write it down and then fill it in. A base area was 400 plus 1/2 times 80 times 24. Oops, not 8. 80 times 24. Okay, so you could, if you're entering it in one of those calculators that can do the order of operations, I guess you can enter it just straight across probably. But if you need to do parts of it, just looking at how some are doing it, what's 1/2 times 80 times 24? If you didn't do that for me. What's 1/2 times 80 times 24? 970? 960? Okay, so 400 plus that sounds like 1,360 square inches for our final answer. And how many got it right? Okay, quite a few on that one. Questions on it? Okay, let's try another one. Let's try this square base pyramid. It looks kind of just pulled out. Does that look way too long? Yeah? Okay. How about if let's just kind of change the picture a little bit. Okay. A triangle. Let's make it a right triangle for the base. Okay, let's go with 6, 8, 10. And then that back one should probably be dashed for 3D. Thinking about what I'm drawing as I'm drawing it. Then to make it a pyramid, I want it all to come up to this point. And I'll switch colors. The slant height should come down to the middle here. That slant height is going to be 18. We'll go inches on this one. Okay, that make more sense for the figure? So triangle base, but then it goes up to a pyramid. Find its surface area. So if it helps, do like what I was doing. List the base area, list the perimeter, list the slant height. The height of the triangle? I mean the base? Okay, so this triangle base, yes, it's a right triangle. So if I would draw just the triangle base, wouldn't this be the triangle base?
Yeah.
Okay, does that help clarify? Yes. Okay, so find the area of the base and find the perimeter of the base. So So that's just the triangle bottom I'm showing you there. Base area was 24. Perimeter was actually 24 also. What's the slant height you're going to do? 18. So your surface area should be the base area. I'm going to write the formula. So 24 plus 1/2 times 24 times 18. 1/2 times 24 times 18 was how much? That's the final answer, right?
Yep.
Okay, hang on a second. I wanted to show my work here. This was 216 and add 24. Your number seems really big.
Oh,
Should be multiplied or something.
yeah, the one had.
240
Yep.
square inches. How many got that one right?
The multiplication of 24 times 1/2.
Yeah. All right. So it seems like we're getting some of those pyramids. I think on something like this, I believe your book has done something like the base area is 50 square inches. And then the slant height, which would come to this point, that slant height is 28. So you don't have to calculate the base area on this one, it already gave it to you. So that's the base area. I guess they'd have to give you a little bit more, wouldn't they? Let's say this edge is 12, and they're all the same. So what would the perimeter be? How many 12s? 5, so that would be 60, and your slant height would be the 28. How did I get this? I made that up to give you the problem. So I'm saying your book sometimes on some of these weird bases might just give you the base so that you can calculate. And question, Lizzie, what was that? Nothing to me?
Yeah.
Okay. So you just had to use that base in your calculation. So 50 plus 1/2 times 60 times 28. So I just made up that 50 when I made up the problem. So just to let you know, that's how they've done a few problems. Okay, let's go to a cone. A cone is kind of like a circular-based pyramid, but it's really not that because it doesn't have straight sides. So a cone is a solid with a circular base and a vertex that is not in the same plane as the base. So the vertex is that like top point. Keep trying to take attendance here is what I'm trying to mess with. It's not letting me do it. We're going to be working with a right cone, and as it says, a right cone is a cone that has the height meet the base at its center. So this cone that I have pictured here If you go from the center of the cone, perpendicular up, that's making a perpendicular height right at the center, that's a right cone. So what would not be a right cone? If that tipped off to the side so that it wasn't nice symmetrical, if it was kind of slanted, that would not be a right cone. It would be more of a yogurt waffle cone or something like that, if it went off to the side. Just like with the pyramid, there's a height and there's a slant height. Now the slant height might be easy to find on this cone because it's actually the edge. It's this side. That right there is your slant height. It doesn't matter which side because think on a cone, no matter which space you go to, that'll be the same measurement. So whether you go here or back here or in the front, those are all going to be the same. There is a nice little right triangle that we might have to use at times. What's the segment called from the center of the circle to the circle? Radius. And then we've got the height going perpendicular to it, and the slant height is like the hypotenuse of that triangle. So if we need the slant height, but they gave us the perpendicular height, we should be able to find what the slant height is. So the height was going perpendicular. The slant height is just going to the point on the edge of the base. And we'll build an example with some numbers. Let's go with 5 for the radius, 13 as the slant height. What's the surface area of that cone? Oh, you don't have the formula.
Is it
Whoa,
5 times
I'm on the wrong-
radius times slant height?
I'm on the wrong screen. Slant height, yes it is. Sorry. Are we done with this screen? I was trying to think what I could do to fill time here, but you're not quite ready to do that one. Whoops. All right, those of you writing, can you zip it down quickly there? Write it down quick. All right, so yes, the bottom will be pi r squared because it's a circle. This slanted part that goes up is kind of a weird shape. You know, if you would undo it, do you remember what it looked like when we looked at the net? We had the circle, and then there was kind of a weird shape. Did I show you this one? Yeah. It kind of had a piece of that. Maybe it was even further around. Maybe it was more like half of a circle. Kind of depends how tall the cone is. But this part is kind of weird to try and figure out. But you take pi times the radius of the circle, and then times the slant height. This will be just a normal circle. So if we add those together, that's what our formula is going to be. And I'm going to flip the screen. If I need to, I'll go back. But here's the formula that I wanted to use. Surface area of a cone, pi r squared, plus pi r L. I'll make that look script again. I have to change the font in my presentation, I think. Now I can put some numbers on here. Should we use those same numbers? Okay, so the radius was 5. The slant height was 13. I wanted you to find the surface area. pi times 5 squared plus pi times 5 times 13, 280. Is that rounded to the nearest whole number?
283.
283. Again, is that rounded to the nearest whole number?
Yes.
Yeah?
So that would be 282.7.
282.7, okay. I was gonna look and see what our directions say on this section, but I guess we'll have to read that when we come to it. Okay, question on that formula. We'll do a few more cone examples on the next screens. Okay, so on this one, let's make the diameter 12 inches, and we'll make the slant 21 inches. Find the surface area. I'm going to look up the directions for your book, see if they go in your phone number in this lesson or not. It does say nearest whole number on the cones. So you can practice that here. Nearest whole number. If you're waiting, think about putting that formula on your note card. So you did pi times, did you use 6 for your radius? 6 squared plus pi times 6 times 21. Radius would just be 6. And if I did it right, to the whole number, 509. Give me a thumbs up or down. 509. Got it, got it? Okay, so cones are fairly easy to do. Things to watch out for, diameter, but you need the radius. I didn't give you the perpendicular on any of those problems, but we'll watch. If they are giving you the height instead of the slant height. How would you do that? Like, for instance, if I had put the 21 here, how could you find that missing slant height? Pythagorean theorem. So watch for that type of thing in those. Okay, so find the slant height. I guess this is exactly what we were just talking about. Okay, radius is 4. Perpendicular height is 12. What's the slant height? To the nearest tenth. The nearest tenth. I'd say the number's a 12. Yeah. This one in here is a 12. And a 4 for the radius. Should it be longer than 12 or shorter than 12? Longer, because it's like the hypotenuse. Anyone having trouble? 12.6? It is longer, not a lot longer, but it is longer. Right, and on the square-based pyramid, if this whole side is 10, when you do the right triangle idea, what is this length on the bottom of your right triangle? It's not 10,
5.
it would be 5, because that's the middle, so that would be half of the 10, how far it is. Right, and then let's say the height here is 20. What's the slant height? No, you don't just add 0.6 every time, but that happened to be 20.6. How are you doing that? I'm doing Pythagorean theorem. I'm doing 5 squared plus 20 squared equals c squared.
No, I
Remember that?
first one, I heard you get 12.6.
Okay, same type of thing, Pythagorean theorem. 4 squared plus 12 squared equals c squared. All right. The other shape is the sphere. And a sphere is a three-dimensional shape. It's not a flat circle, it's a three-dimensional circle. So it's like a ball. Sphere. A set of all points in space that are the same distance from a center point. Same distance from a center point. So there is a middle center point on a sphere. Because we're going to need to know the radius of the sphere. So they can either picture the radius for us, or they can draw it all the way across and give us the diameter. So same kind of thing we did on circles. We need to watch for the radius. The surface area of a sphere is related to the biggest circle that you could get when you slice a sphere. Where would you cut through, it's called cross-section, where would you cross-section and get the biggest circle possible? Right through that middle. Yeah, like the hemisphere, you can maybe see a plastic here, like the equator of the Earth. So that would be your biggest circle that you could do. And if you would take, where the plastic? Here, I got the. So if you would take 4 of these circles, that's the amount that you need to cover the whole ball, the whole sphere. 4 of these great circles. How can I show you that? I have a softball that we took the leather off of. And they're not going to be perfect circles, because if it's perfect, you wouldn't be able to get the next one to fit with it correctly. But if I peel off the leather, you can see, okay, it probably took a circle to make that one, but it was squished a certain way so it would fit in the leather. So there's 1 circle, there's 2 circles, and there's 3 and 4. You can visualize where those 4 circles come from. 1, 2, 3, 4. How do you find the area of 1 circle? 1 circle, pi r squared. So if you need 4 of them, the formula is going to be 4 times pi r squared. Okay, so let's see, is that my next screen? Yes. Okay, surface area of a sphere is simply 4 times the area of that great circle, the biggest circle you could get. 4 times that. So 4 pi r squared. And then think about your note card. The sphere surface area of the note card. So let's do a surface area. Radius is, I've been using 8s quite a bit today. Let's go 8 inches for the radius. So that's a pretty big ball when you think about 16-inch diameter. But what's its surface area? How much leather would it take if my softball was that big?
Are we rounding this?
Yes, nearest whole number I think is what they probably did again. 4 times pi times 8 squared. 804?
Yeah.
There's a 0 in there, right?
Yeah.
804? Yes, yes, yes. 4 times pi times 8 squared, 804. Square inches, we'll say approximately because we rounded that. The great circle is the largest circle that can be sliced from the sphere. If you slice out further on the sphere, you'll still get circles. You'll get smaller and smaller circles as you go out. The biggest one would be right at the equator, right through that center point. Okay. Think you're caught up on notes? So let's say on this one, the diameter is 6 inches. And notice where I put the 6, kind of spaced in the middle, so that's the whole diameter, it's not just the radius. Okay? Figure the surface area of this smaller sphere. Use the radius or the diameter. Radius is what? 3. Okay, radius is 3. So you did 4 times pi times 3 squared. I got 113. 113 square inches. So we did one with diameter, one with radius. Watch for those. All right, shall we run through a practice problem of each? I plan to give you a quiz tomorrow, so it might be good if we can do a practice problem of each one of these.
That's right, kind of.
Yes, you got the assignment from over there?
Yeah.
All right, on this one, let's go with a 3, a 4, and a 10. What's the surface area? You should have your note card. What shape is this one? Rectangular prism. So there's a formula for prisms. When it says B, that means base area. How you find it depends what shape that base is. You have to use the area for the correct shape to do your base area. 3, 4, and 10 I have. Comparing with your neighbor. Okay. Now we look for the right formula.
2 feet plus H.
And B was just a rectangle, 3 times 4. Perimeter, 3 and 4 is 7, and another 3 and 4, so that was 14. What else do I need? H? 10? Okay, so 2 times 12
24.
plus 14 times 10,
164.
164 total. Get it right? Questions? This one is surface area, but it's for what shape? Prism. Well, prism surface area. We did that yesterday. All right, let's do a pyramid. Okay, so look at your notes, pyramid. And I've got just a square base pyramid. Let's go with 12 by 12 for its base. And its slant height, that goes up quite a ways. Let's go 39. Find the surface area. This one is a pyramid. So there's only one base. The base area was 12 times 12. The perimeter was 12 times 4. And we have a slant height of 39. All right, so just to double check, 144 plus 1/2 times 48 times 39. And if I did that right, 1,080?
Yep.
Yep. Okay, square inches. That one's a prism or pyramid. Next one. What shape is this? Let's go with 14 inches. This one's a sphere. Nearest whole number? 2,463? Okay. Good. How about a, oh, kind of late at that direction this time. This edge is going to be 30 inches. And probably would be easiest for me to say this whole thing is 40 inches. Find its surface area to the nearest whole number. Pi times, what was the radius?
20.
20. So pi times 20 squared plus pi times 20 times 30. And I get, is that 3,142?
Yes.
Round up. 3,142 square inches. Have you got that one right? Okay, so what shape is left? Cylinder. I've got it turned sideways. Really tall. This time it's 50. And then this measurement is 36. Okay, this will be the last one, then we'll work on your assignment. It's a cylinder laid on its side. Cylinder. Didn't leave myself much room to write. Cylinder was part of yesterday. So it's on the left-hand brown poster, the one that has the pies, the surface area. So it's 2 pi r squared, because there's 2 circles, and plus 2 pi rh. Radius is 25. And the height is, that's the 36. getting 9,582? Yes. Okay. So we went through one of each shape. So homework. And the assignment was over there at page 495. It's actually on multiple pages because we did some from more than one section. That's not showing up very good. Numbers 1 through 8, and then evens on 10 to 36. On 520, these are the spheres. We'll just do 8 through 22 even on that page. Since we have a quiz tomorrow, give you a little bit that has every shape, 1 through 9. Yes, I usually allow the number.